Start section 3.1, which is the section on graphing in the coordinate plane. So 3.1 is graphing in the coordinate plane. All right, I want to go down, and if you have notebook paper with you, you might just, bless you, you might just go to some notebook paper, and I'm going to draw a coordinate plane right here. Yours will probably look better than mine. A coordinate plane is made up out of a horizontal number line and a vertical number line which are perpendicular to each other. Now, this one time, I'm going to go ahead and label this. I'm going to use a thin pen to label it. This would be 1, 2, 3, 4, 5, 6, 7. And going to the left, it would be -1, -2, -3, -4, -5, -6, -7. That, of course, means that 0 is in the middle. With the vertical number line, up is going to be the positive direction. So I'm going to label it 1, 2, 3, 4, 5, 6, 7. Down will be the negative direction, -1, -2, -3, -4, -5, -6. And you certainly, these number lines go on forever. So if I wanted to put some more numbers on there, I could. The horizontal number line, which goes in both directions forever and ever, is called the x-axis. Letter X, the x-axis. The vertical number line, which goes up and down forever, is called the y-axis. And that needs to be burned into your memories forever. The horizontal one is X, the vertical one is Y. Now, if you have ever played the game Battleship, how many of y'all have played Battleship? Okay, if you got kiddos, you might have played it recently. Now they have, of course, electronic Battleship, but in the olden days, we just had little old pegs to stick in there. Yes, okay. When you play Battleship, it looks more like this, okay? And on one of these, and I don't know which one's which, they might have A, B, C, D. And the other direction, they might have 1, 2, 3. So that every little location, and these are, well, at least they used to be little holes that you put pegs in for your battleship or something. Every one of these locations has a name. The person you're playing with can't see your battleship grounds. So if you are talking about this location, you have to be able to talk about it with words, and they have to know what you're saying. And it would be called something like C2. Why? Because it is at the intersection of where C is and where 2 is, C2. Is everybody familiar with that, maybe with the game? When you use a map, if you are looking up a street in a city map, there will be an entire listing of all the streets. And you look one up and it says E5. So you look on the edges of your map, you find E, you find 5, you come together, and there's the thing you were looking for. Okay. In those settings, usually one of the axes has letters and one of the axes has numbers. That doesn't work real well for us in math. In math, we have numbers going both directions. So you could see that it could get confusing, couldn't it? But it won't, because we're going to have a rule right now. When we name a location, we are going to name the location always, always, the X number first and the Y number second. Always X, comma, Y. And that should be easy to remember because that's also alphabetical, X before Y. Okay? This naming of a location is called an ordered pair. And that's a good name for it because it is a pair of numbers and the order is significant. X, then Y. Sometimes these are called coordinates. Okay? Now, the first skill that you need to conquer is being able to name points. Okay, so I'm going to put, and I'm sorry, might be a little bit tiny for those of you in the class. I'll make it a little bit bigger. I'm going to put a point, and I'll do it in blue, maybe it'll stand out. I'm going to put a point right there. And I would like you to name that point with an ordered pair. What will it be named?
4, 1.
It will be 4, 1. On the x-axis, if 0 is the starting point, this is at 4. And on the y-axis, it's up 1. So as an ordered pair, it is 4, 1. And anybody, you could be talking to somebody on the phone, and you would say, okay, you were doing the homework? Well, on that problem, put your point at 4, 1. They would know. Start at 0, 0. Go 4 in the x direction. Go 1 in the y direction. Put a point. Okay, let's do another point. Let's suppose and I hope you can see that point okay. Can you name an ordered pair for that point? Yes, that would be the point -2, 3. Because to plot that point, I always start right here, and by the way, there's a name for this. The point right here, where the 0 is called the origin. And origin means beginning. It is where you begin. So if you begin there, if you go 2 to the left on the x-axis, 3 up in the y direction, there's the point. All right, what about that point? Can y'all see that one okay? It is the point -3 in the x direction, -3 in the y direction. From the origin, to get to that point, you would go left 3 and down 3. Every one of these points is an x, y. All right, one more on, what about that point right there? It is supposed to be, and it's a little iffy because I don't really have a grid, it is 6, -2. Can you see that it could be a huge problem if you get the two numbers reversed? You're going to go in the wrong direction. Yeah. So we have to all be in agreement, and if you like it or not, you have to agree with it, that the x comes first and the y comes second. All right, now, what about if I plotted a point that was on an axis? I made a big old point there. What would be the coordinates of that big old point?
0, 2.
All right, first thing I heard was 0, 2. If I start at the origin, and if I go 0 in the x direction, then I don't move. And if I go 2 in the y direction, I'd be up here. So I think we're going to need to revise that.
It'd be 2, 0.
Excellent. 2, 0. It's a little squished in there. But that is, well, let me see if I can. I want to write it better. Okay, because from the origin I went 2 to the right, but I did not go up or down. That left me on the x-axis. What about this point? What would the coordinates of that point be? Okay. Okay, if it is 7, 0, Do I go 7 in the x direction?
No, it's 0, 7.
It is 0, 7. The points on the axes tend to get more confused than any other.
So you've got
From the origin,
thought the other way too.
did you move right or left to get to that point? No, you stayed, so you moved 0 in the x direction, but then you moved up 7. Okay, what about this point?
0, negative 5.
Okay, think about it carefully. Negative 5, 0, because you moved in the x direction and then you didn't move up or down. Very easy to get those confused, but think about them very carefully and remember that it's always the x motion first. And then finally, let's name this point right here. How do I move in the x direction? You don't.
0 first.
And then you move down 4, which is negative 4.
So your starting point is the first letter.
Yes.
Or
Well,
number.
the way you move horizontally is the first number, and the way you move vertically is the second number. So it is x.
goes before Y.
Okay,
before
so
Y.
basically you just need to remember that if you're not moving horizontally, it's always going to be a 0.
Yes, ma'am. And if you're not moving vertically, the second number is going to be a 0. So, having said that, what do you think we name the origin? It is 0, 0. The origin is 0, 0. You always start at the origin, and if you're not going to move right, the x is a 0. If you're not going to move right or left, x is 0. If you're not going to move up or down, y is a 0. Okay, my graph's going to get a little more cluttered here. Do you recognize that this big giant plane, which is this flat surface, has been cut into 4 regions by letting these two axes intersect? The first region is the upper right-hand region. I didn't decide this. This was decided for me. And let me get to a thicker one. I'm going to use a Roman numeral 1. This is called quadrant 1. Each of these regions is a quadrant. The prefix quad means 4. So these are the 4 regions. For some reason, we go counterclockwise, and so this is quadrant 2, which makes the bottom left quadrant 3, and the bottom right quadrant 4. There. Uh-oh. Please come back. There we go. All right, so those are the quadrants. Sometimes you are asked questions like, where is a particular point? Which quadrant is it in? So, although you do not need to memorize what we're about to say, it might be helpful to think about it once in a while. If you are a point in quadrant 1, then what kind of numbers will the points have as their ordered pairs? Positive. Because if you're in quadrant 1, you went to the right and you went up, and those are both positive directions. So in quadrant 1, it is always a plus, comma, a plus. You don't have to memorize that. If you were in quadrant 2, that means that you started at the origin, you went to the left, which is negative, but you went up, which is positive. So if you're in quadrant 2, it is a negative and then a positive. Quadrant 3. What kinds of numbers will you find in quadrant 3?
All negatives.
Yes, because you will have gone left, which is a negative direction, and you will have gone down, which is a negative direction. And finally, for quadrant 4, what will it have as its signs?
Positive, comma, negative.
Positive, comma, negative. When you are on the x-axis, you will always have a number, comma, 0. because you will not have, oh, thank you. Those of you in class don't know where I was writing. So if you're on the x-axis, you will get a number, but you will not be moving up or down, so the y is 0. And if you are on the y-axis, what form will the points take? 0, comma, a number. Because you will not have gone right or left, but you will travel either up or down on the y-axis. So if you printed the notes, then now let's go to our grids. That was a lot of introduction. And the first thing I'm going to do is I'll leave it like this, and then if I need to enlarge the grid for those of you in class, I will. It says, number 1, plot the ordered pair 3, -1. State in which quadrant or on which axis the point lies. Okay, I need to plot 3, -1. All right. Now, when you do this in MATLAB, you will have the opportunity to pick up the point. If we have time, we'll go into it and take a look. You're going to pick up the point that's sitting at the origin, and you're going to take it to this location. All right, where would I take this? Which way would I move?
Quadrant 2.
Okay, it will go, tell me right or left, up or down. How will I move?
Right.
Right 3 and down 1?
Yep.
Okay, so here's my location. Is everybody okay with that?
Yeah.
Okay, that's where it will graph, and you will physically move this little point to that location. And then it says, in which quadrant is that? Well, then I hope you remember that the quadrants are numbered like this, and it always starts with the positive is the first quadrant, and it goes counterclockwise. So, which quadrant is it in? 4. Is everybody okay with that? And we went the x first and the y second, always x first, y second for ordered pairs. Okay, now they have in this one, number 2, it says find the x and y coordinates of point B. Okay, now they gave us a lot of points to look at. So those of you in class, I'm going to enlarge that a little bit. Do you see point B right down here? All right, so it wants me to give the coordinates of that point. Now you're on an axis, so be careful. From the origin, how do you move horizontally?
You don't.
You don't. So the
0,
first,
-1.
so it is 0, comma, down 1 is -1. When it says here in the instructions, type an ordered pair, then you're going to need to put parentheses, 0, comma, -1, close parentheses. Now be careful. I don't know if this is still this way or not. There was a time when you would look at MATLAB and you'd look over at the toolbar and you would see something kind of like this. And you might choose it and put the numbers in, and then it was telling you it was wrong. How could it be wrong? I think it is not a good thing, but they used to have this up there, and it was interval notation. Because you can't tell. This kind of looks like the interval from 0 to -1. It's not, it's an ordered pair. So, I would say just type in the parentheses off your keyboard. All right, let's look at number 3. It says find the coordinates of point C. So picture. This time they didn't give us any clutter. We've just got this. Okay.
4, 3.
All right.
Why do I keep thinking that's negative?
All right. The point is 4, comma, 3. And that's all I put on there. Why? Because from the origin, it is right 4 and up 3. Okay? Let's keep going. Number 4. It wants us to find the coordinates of point E. Okay. You get to have your negative number this time. All right. From the origin, the x direction, I go left 4, so that's a negative 4. I go down 3, so that's a negative 3. Are we doing okay? What you have to remember is it is always, always start at the origin. How do you move left or right? How do you move up or down? Okay. Number 5, very much like that. Here's my point E that I'm supposed to name. It is the point from 0, 0. I have to go left 2, so that's negative 2. I have to go down 4, that's negative 4. Always remembering that it is X, Y as far as the order. We okay? All right. We have a new job, and there's no grids for these next ones, and I will try to write, well, small enough for us to read, but large enough for us to read. Okay. It says the following. Determine whether each ordered pair is a solution of the given linear equation. Now, I want to pause for a minute. I'm not going to pause the recording. I want to leave number 6 for just a minute, and I want to go down to a blank spot, and I want to write down the kind of equation that you studied prior to today. Let's suppose I have x plus 4 is equal to 7. And I ask you a question. Is 3 a solution? And you answer immediately, yes, it is. Now, how did you know that?
Because 3 plus 4 is 7.
All right, because 3 plus 4 is 7. So the answer is yes, 3 plus 4 indeed does equal 7. In other words, you checked it. You plugged it in, and it made a true statement. Agreed? That's what it means to be a solution. It means if you plug it in, it's the right number to make it true. Now, the problems that we're about to look at today have more than one letter in them. So I'm going to try to copy it. Here's the equation. 4x plus 5y is 17. Now, this is called a linear equation, and sometimes it's called a linear equation in two unknowns, two variables, x and y. So if they're going to ask me if something is a solution, they're going to give me an ordered pair, which is an x and a y. They want to know, is 3, 1 a solution? Well, what's going to be my process for checking? Plug in. And you've got something to plug in for x and something to plug in for y. So it's going to be, question, this is a question, is 4 times 3 plus 5 times 1 equal 17? Now, some people can tell right away. Other people might say, well, I need to simplify a little bit. 4 times 3 is 12, and 5 times 1 is 5, and 12 plus 5 is 17. So now, is 17 equal to 17? Yes. So is that a solution? The answer is yes. If when you plug in the x and the y, you get a true statement, you get to answer yes. Then they ask me another question, and by the way, it's the same equation. I still have 4x plus 5y is equal to 17, and the new point I'm checking is 8, 0. Okay, so the process would be, is 4 times 8 plus 5 times 0 equal to 17? No. The left-hand side is equal to 40, and the right-hand side is 17, and that means no. Duh, I'm sorry. Y'all are wondering, and where did you get 40? I have no clue. How about 4 times 8 is normally just 32? Plus 5. I don't know. I guess I saw the 5, I saw the 8. I didn't get enough sleep last night, and so did some creative multiplication. But luckily, my answer was right anyway. No, it was just correct for the wrong reason. All right, last one, same equation, 4x plus 5y is 17, and please check the point 0, 1. So is 4 times 0 plus 5 times 1 equal to 17? And the answer is no, because what is the left side equal to? 5. And 5 is not the same as 17. So it's no. So although we may not know a whole lot more than this right now, we know that an ordered pair can be a solution to this kind of equation if and only if you plug in the x and the y and it makes a true statement. The first question on your test over chapter 4 will be, is this particular point a solution to this particular equation? And you'll plug it in and check. Okay? All right. In these next ones, I may not check all of the parts. All right, number 7. It says determine whether each one is a solution, although on this one maybe I will. The equation is x equals negative 3/5 times y. The point that I'm supposed to check, it's not bad. It's 0, 0. The origin. Let's see. Putting in 0 for x, I get 0 is equal to negative 3/5 times 0. Well, the left-hand side stays a 0. The right-hand side is equal to 0. And so my answer for that very first one is yes. 0, 0 is a solution. Now, by the way, I have not shown you how to find solutions. All I've shown you so far is how to test a given ordered pair to see if it is a solution. All right, the last part of that, I'm still using x is equal to negative 3/5 y, and I am checking the point negative 3, 5. Okay, putting in negative 3 for x is equal to negative 3/5 times 5. Okay, on the left-hand side, it stays negative 3. On the right-hand side, the number that's not a fraction, I can turn it into a fraction by putting it over 1. Can I do some reducing? Do you agree that those 5s divide out? And what are you left with on the right-hand side? Negative 3. So the answer to the question is yes. Are you pretty satisfied with checking an ordered pair to see if it is a solution? All right, and then I've got my drawings for the rest of that. So we're going to call that, that is all we have on 3.1, isn't it? Those of you who printed the notes?
We have 2 more pages.
Oh, great. Where did I put them? All right, let me look down here. Are they hiding somewhere? No. Okay. Well, so, yeah, yes. I'm so sorry. I thought it had all transferred over there. There's not any graphing anymore, so you'll be okay. All right, number 8. Oh, I thought I had paused. I didn't. There will be a little dead time on the graph. I mean on the recording. Problem number 8. We're still working, and I'm not going to do all the parts to this, but it says determine whether each ordered pair is a solution. This equation looks a little weird. And in the context of what we're doing, it is a little bit weird because it looks like somebody forgot to put the y in there. All right, I have the point 7, 0. Is that a solution? Well, my equation only has an x in it, which means I only get to plug in the x. And what it really tells me is that the y is irrelevant. It must not matter. So if I plug in the x, is 7 equal to 7? Yes. The next point they give you is 2 comma 7. Now you have to be careful because the minute you see the 7, you're thinking, oh yeah, but what number are you plugging in? The x, which is a 2. So is 2 the same as 7? No, that's not a solution. The third one is the point 7 comma 8. You're still plugging in the x because the equation says x equals 7. So 7 equals 7 again, and that's a yes. And the same thing could be true if the problem had just had a y in it. You would be plugging in just y numbers. So kind of unusual, just plug in x. Y doesn't count at all in this problem. Now it changes types of problems completely. And there are some tables to fill in. And the tables, when I write the tables, as opposed to the way they're written in MathLab or in a textbook, I tend to not close it up to be a complete table. I usually make it look kind of like this, and it is called a T-chart. T-chart. A T-chart is a chart that can hold ordered pairs. It can hold an X, I have highlighted the X spot, and the Y that goes with it. So a T-chart or a table can hold an ordered pair, an X comma Y. All right, what they ask of you is they give you a 0 and they want you to fill in the Y. They give you a 4, they want you to fill in the Y. And they give you a -1 in the Y, and they want you to fill in the X. And, you know, I just probably shouldn't even try to change color so much. There we go. They give you an incomplete table. And they say, here's an equation. They have to give you an equation. The equation for number 9, this is problem number 9, is y equals 10 times x. All right, here's my linear equation. The instructions say complete the table of ordered pairs for the linear equation. All right, now complete it. What does that mean? That means take the number that's given, plug it into the place it should be plugged in, and see what the other letter's value is. Okay, let's do part number 1. Part 1, or I'll call it I for part 1. All right, x is 0. How do I know that? It is right here. X is 0. So I'm doing this part right here. I'm going to take y equals 10x. I'm going to plug this in the place of x. Y is equal to 10 times 0, which means what is the value of y? 0. When x is 0 and I plug it in there, the y turns out to be 0 and I fill that in. What I have done is they gave me one of the letters. I plugged it in and I cranked out its partner. The partners together form an ordered pair, which is a solution. All right, the second part, I'll call it II. All right, this time, what have I been given for part 2? X is 4. My equation doesn't change. It is y equals 10 times x. I'm going to plug the 4 in the place of x. Y is equal to 10 times 4. What is the value of y? 40. 4 matches up with 40. The ordered pair 4, 40 is a solution. It will make the statement true. There's 2 solutions to this so far. Okay, part 3. I don't know why I went to this weird numbering system. What are you given in part 3?
The y.
The y. You're given that y is -1. The equation is still y equals 10x. So what do I plug in where?
-1.
Goes in for y. -1 equals 10x. Now, it's a little more work for me to solve for x, but we're supposed to be virtual experts at solving equations. So what would you do to get x by itself? You would divide by 10, divide by 10, that would go away, and you'd have x is equal to, you might not like it too much, but you have a fraction for x. It is -1/10. And so back in the chart, you would have to use your little fraction key, and it is -1/10. And you could put the negative either with the top, out in front, or even with the bottom if you wanted to. Now, summarizing what we did, we were given a table that was only half filled in. Sometimes we were given an x, we plugged it in and cranked out its partner y. One time we were given a y, we plugged it in to crank out its partner x. So if you just give me one of them, I can plug it in and find its partner. Together, they make a solution which takes on the form of an ordered pair. This is the point 0, 0. All of a sudden I'm talking about points. They are points, and we're going to get further with this. Okay? We do some more of this. Number 10. All right, I'm supposed to complete a table. And I have 0 for x, 0 for y, -8 for x, and I need to fill in the others. And I have the equation y equals -x minus 1. That negative sign in front of letter x means whatever the sign of x is, you're going to end up changing it to its opposite. So, does everybody see that I have 3 problems to do here? Okay, the first one, x is 0. Y equals -x minus 1. You're going to plug in 0 in the place of x. Y is equal to opposite of 0 minus 1. But the opposite of 0 is 0, so that term really is gone. Y is -1. When x is 0, its partner is y equals -1. What am I given for the second part? You're given a y. You're given y is 0. So the equation is y equals -x minus 1. You're going to plug in the value for y. 0 is equal to -x minus 1. Something that you may notice on some problems is that it's easier when they give you an x. Because when you get a y, then you have to actually solve it. So I'm going to add 1 to both sides. So I have 1 is equal to -x. Is that finished? No. I need to divide by -1. So 1 divided by negative 1 is negative 1 is x. So I will fill into my chart that when y is 0, x is negative 1, and I had to do a good bit more work there. All right, the last one, what are you given? X. You're given that x is negative 8. So the equation is y equals negative x minus 1. Plug that in. Y is equal to the opposite of negative 8 minus a 1. And I heard an uh-oh. What that means is we just need to be careful. Y is equal to, what's the opposite of negative 8? 8 minus 1. So y is 7. So sometimes it's just do a little arithmetic like it was here. Sometimes it means solve an equation, moving things from left sides to right sides and dividing and so on, and it just depends on the kind of equation. We found 3 ordered pairs. Each one of them is a solution to this equation. Now, I'm not going to do any more of this one, but if I told you x is 5, could you find a y to go with it? If I told you x was 19, could you find a y to go with it? If I gave you any number on earth for x, could you find a y to go with it? And same thing with y. How many solutions then could there be? An infinite number. There is no limit to the number of solutions. And we'll talk more about that. All right, number 11. I'm supposed to do the same thing with the table. And I have a table. I have 0 for x, negative 10 for x, and 6 for y. And I am told that the equation which relates the two is y equals 1/2 x. And don't get in a snit because you see a fraction. You're just going to handle it. Okay, first part, x is 0. The equation is y equals 1/2 x. So what are you going to do what? What are you going to do where? Put that 0 in for x. So y is equal to 1/2 times 0. And 1/2 times 0 is? 0. So that tells me that the origin, 0, 0, is a solution. Next part, x is negative 10. I have y equals 1/2 x. Plugging in the negative 10, y is equal to 1/2 times negative 10. Well, what's half of negative 10? Negative 5. Now, if you wanted to, you could have put that negative 10 over 1 and done your little reducing, and you'd get the same thing. 2 goes in there once, 2 goes in there negative 5 times, and you get negative 5. Or you just could have taken half of it. So, y is negative 5. Last part of that, you are told y is 6, and y is equal to 1/2 x. Let me scroll. In this one, you've got to put the y in. So 6 is equal to 1/2 of x. Now you might just be able to figure it out in your head. Half of what number is 6?
3.
No, not half of what is half of 6. Half of what number will give us 6? 12. 12. But here's the process if you want to know what the process was. Do you see an equation with a fraction?
Yep.
Our process is multiply everything by the LCD, which is 2. So I would multiply 2 times 6 equals 2 times 1/2 x. 2 times 6 is 12. What happens when you multiply 2 over 1 times 1 over 2? Cancel out, and I get x. So whether you did it just logic or whether you did it algebraically, x is 12. When you are completing a T-chart, you are finding a friend to go with a given value, and together they make an ordered pair, which is a solution. Is that okay? Did you notice that it seemed to be easier for most of these problems when we gave you an x and you cranked out the y? That's because it is typical for these equations to be in the form y equals. Because of that, the next exercises, which are kind of abstract but very important, ask you, and we've actually done something like this before, back in chapter 2. It says, solve for y. This is going to be really, really important for the whole rest of your math life. And it says 4x plus y is 16. I want to rewrite this so that it says y equals. I want y to be all by itself. So I look at the side that has the y, and I notice there is a 4x over here that I don't want here. I want to get rid of it. How could I get rid of a 4x that's been added to this side? Subtract it. I'm going to subtract this entire term of 4x. But if I do it to the left side, do it to the right. On the left side, it cancels out, and I must be headed in the right direction because my statement now says y equals. And now pause for a minute. Do you notice that these are not like terms? Which means you cannot crunch them into one single thing. You have to leave them. And here's the order that is preferred. Put the x term with its sign first, negative 4x. Put the constant term with its implied sign second. Oh my goodness, what did I just hit? Okay, we're back. Make that go away. Stop. Ooh. Okay, plus 16. If you did 16 minus 4x, it would be okay. I don't know what MathLab would say about it, but I would just like you, it would be correct. Mathematically, it would be correct. But I think it is important that you go ahead and get in a habit of putting the x term first with whatever its sign is. So if it's positive, put a plus, and if it's, there won't be a sign, but if it's minus, you'll put a negative. Okay, let's look at another one. We're still solving for y equals. Solving for y. And the equation is 4x plus 7y is 28. Now what am I solving for? The y. Okay, which means what do I need to get rid of? 4x needs to go away. So I'm going to subtract 4x. Sure enough, it's gone from the left. I have 7y is equal to, how am I going to write the right-hand side? Negative 4x plus 28. Am I through? Does it say y equals? No. Well, 7. 7 is the coefficient of y. What do you need to do? Divide both sides by it. Now, when you divide it, and on the right-hand side you have more than one term, it is in your best interest if you just write it underneath each one of those. So when you divide by 7, you divide everything by 7. And you get y is equal to. The coefficient of x is that fraction. It is negative 4 over 7x plus, what's 28 divided by 7? 4. And by the way, never ever write a mixed number down. If something's improper, leave it improper. If it's a proper fraction, just make sure it's reduced. Here's your answer. That's the equation in the form y equals. And there is one more. Still solving for y, and it says 50x is equal to negative 5y. Now, what is it I want by itself? Y. So this number right here, this negative 5, is it being subtracted, added, multiplied? What's it doing? What's going on?
You have to add it to get rid of it.
Now, if I add it, this is negative 5y. What? There's no sign there. What does that mean is going on? That's multiplication. So we need to divide by negative 5. That is the coefficient. That leaves me on the right-hand side with a y. And can you divide over here? Yes. 50 divided by negative 5 is negative 10. So I actually like to read this, y is equal to negative 10x. What you'll be filling in will just be this side. It will say y equals, and you'll fill in. Okay, so I'm going to stop 3.1.